Hi, in this video we are going to learn about Shannon Hartley Theorem. He is Dr. Sridevi, Professor, Department of Electronics and Communication Engineering, Rohini College of Engineering and Technology. So on completion of this module, the students will be able to understand the concepts of Shannon Hartley Theorem. So in information theory, this theorem tells the maximum rate at which the information can be transmitted. That is, how many number of bits are transmitted via the transmitter can be determined by this theorem. So we already known that information is transmitted through a channel with rate R. It is called as information rate. So this rate is important uh, for calculation of channel's efficiency. So it is done by using this Shannon Hartley theorem. So the application of noisy channel coding theorem to the continuous time analog time signals are subjected to Gaussian noise. So to calculate this noise, this theorem establishes for such a communication link which is bound of maximum amount of error-free digital channels. The information rate, that is which is arbitrarily small probability of error. It is provided by the channel which is channel's rate or channel's capacity C. So Shannon relates this to the rate R and channel capacity C. Both are related by Shannon, which is called as Hartley-Shannon theorem. C is the capacity of the channel. So channel capacity is the maximum information rate which the error probability is within the tolerable limits. Always the error probability should be within the tolerable rate. So this law is named by Shannon and Hartley, two scientists. So that combined name Shannon Hartley theorem. So it purely depends upon the channel capacity C and bandwidth B. So C and B are related in such a way that C is equal to B into log to the base to 1 plus S by N. S is the signal power, N is the noise power. So while converting this to log 10, it will be B log to the base 10 1 plus S by N divided by log 2 to the base 10. So this is the graph which relates the spectral efficiency and EB by N naught. EB is the energy by noise ratio and spectral efficiency. Whenever R is greater than C, it is obtained by this graph. And when R is less than C and R is equal to C, when R is equal to C, it represents the blue line, and R is greater than C, it represents the red line, that is unattainable, and R is less than C, it is practical systems. So it's the comparison between RB by EB by N naught and efficiency eta. So this theorem always states that R is less than or equal to C. The channel capacity C should be always greater than the rate of number of bits transmitted, that is the information rate. So the relationship between C and B, which is given by Hartley-Shannon theorem, is C is equal to B log to the base to 1 plus S by N, where C is the channel capacity. It is determined in bits per second. That is, this theorem states that whenever if R is less than or equal to C, it is possible to transmit information without any error. So even if noise is present, coding techniques are used to detect and also correct the errors. B is the bandwidth in hertz, and S is the average received signal power over the bandwidth, and N is the noise. So S by N is the signal to noise ratio. So SNR represents signal to noise ratio and CNR represents carrier to noise ratio. So this theorem, Hartley-Shannon theorem, which is mainly used in the applications such as Hoffman coding, and which is not always optimal among all compression methods, and it is used in discrete memoryless channels to find 100% efficiency using these codes. And finally, this Hartley-Shannon theorem states that R is less, always information rate R is greater than C, that is R is always less than C, that is always the capacity should be greater, channel capacity should be greater. The negative statement of this theorem is R is greater than C, that is the probability of error is close to unity for every possible set of M transmitted signals. Thank you.